The next item we need to learn in this topic on analytical approaches to modern geometry is a review on the inner product spaces. The inner product spaces are also known as inner product of, let's say, two vectors. Dot product or scalar product is one essential item as we move further in topics in modern geometry, or again in the analytical approaches. So in this video, we're just going to illustrate how is it done. So let's say, for example, that x here, a vector, and y, both of them are in R2. So we have these components, x sub 1, x sub 2 for x, y sub 1, y sub 2 for y. The inner product of is actually denoted as this. You have this notation, x and then y. Okay? This means we simply need to multiply the first components and then add it to the product of the second components. You have here x sub 1 and y sub 1 plus x sub 2, y sub 2. Okay? So it's just as simple as that. And take note that once you multiply this, and this video will be very short because we will have an illustration on it later on. We have some examples together with some properties. This tells us that the inner product, or the result for inner product space, or the inner product space is actually a scalar. Okay, an element of real number, because these two are real numbers, and when multiplied, we will get the real number, same as this. And when we add real numbers, this will always be real number. So when adding vectors in the previous discussions, the result is vector. When we have a scalar to be multiplied to a vector, the result is still vector. But the inner product space of two vectors is a real number. Take note of that. We will have proof for some properties on inner product space in the next few videos and some examples to be solved. Thank you very much for watching.